Welcome to the data cleaning. In this particular section, we'll be examining data cleaning, a very important task in most NLP processing activities. We will find that it's very important to ensure that data is in a consistent and valid state. If it's not consistent, if it's not valid, then quite often the results further analysis will be incorrect or misleading. In this section, we'll learn how to perform basic cleaning operations. These things may include things such as removing white space. There are other activities we will not be examining, such as finding, replacing text, and subsetting data, but these are fairly straightforward. We'll also examine how to remove stop words for text. Stop words are words that are not necessarily relevant to certain NLP processing tasks. For example, stop words may include the words such as the, a, and, etc. When they're not necessary, we can improve the efficiency of our analysis quite often by removing these words. The last thing we'll be looking at is how to validate text or validate our data. In this case, there'll be a number of different types of data we may want to validate, such as are our dates or numbers in a correct format? Are the zip codes we're using valid zip codes, or at least in the right format for zip code? The same thing can be said of other types of entities, such as phone numbers or emails. Performing basic cleaning operations. In this video, we are concerned about cleaning text, making sure it's in the correct format. We will look at basically how we use simple techniques to clean our text so it has fewer discrepancies, if you like. We'll look at how to remove stop words. These are words that may or may not contribute to the further analysis. Often it's nice to remove those to make the downstream processing more efficient. And we'll be looking at techniques for validating data. All of this will be done using both core and some Java libraries. So let's get started. In this video, we're looking specifically at basic cleaning operations. In here, we'll look at different techniques available to us. We'll focus on removing white spaces from text. We'll bring up NetBeans, create a project that demonstrates several of these different techniques. It's important to clean the text before we start using it. By cleaning, we talk about doing things such as removing unnecessary white space. Sometimes we may want to replace text. For example, perhaps we'll want to expand acronyms. We may deal with data imputation, and we may deal with subsetting of text. Data imputation deals with providing data or filling the blanks, so to speak. For example, you may have a spreadsheet where some of the numbers or some of the fields are empty, and to do proper analysis, we may need to actually use good numbers for those missing elements. To do so, we have sometimes used interpolation or some other technique to figure out what would be an appropriate value to place there. In this video, we're not going to look at that particular technique, but it is application specific. Subsetting text is concerned with how to go out and remove portions of the text you want to process. For example, you may have some census data for a country. You may want not to analyze the entire country, perhaps only a county or a state or a province or some other unit of that nature. That's subsetting the text. So the idea here behind all the basic cleaning operations is assure that the text is in a correct format and that we have it in standardized form before we actually perform the analysis. So let's go and look at the process of removing white spaces. We're going to demonstrate 3 different techniques for removing white spaces and 1 technique for selecting what text we want to retain from a document. White spaces may sound fairly trivial. It's really not necessarily that hard, but there's several issues we want to address here. We'll be using some of the methods of the Java string class. It has some limitations. We'll also be using the Google Guava project. We'll use specifically the splitter and chart matcher classes to some of these tasks we have outlined here. Google Guava is found at the following website. Let's go look at that. What we see here is a string called text. I have it split across 2 lines here. It has embedded into it extra blanks like we see between the word demonstration and of. And this will give us an opportunity to demonstrate how to remove white spaces necessary. We then simply print it out to see what it looks like. I need to fix my imports by right-clicking. Fix imports. I want to use a Java out object. I need to use a static import statement as we see here. We need to go ahead and we need to make sure we have available class. In this case, it's going to be the basic cleaning operations class. Select the main class, run our application, and we see here the output, original text, simple demonstration, etc. And notice all the embedded blanks in our text. These are what we want to remove. So, first of all, we're going to use basically the string classes methods to do the operation. So again, I'm going to copy and paste this code in here to save a little time. And what we're going to be doing here, basically, first of all, clean the text out. So I'll create a string called clear text. Go ahead and format this. Cleaned text. I'm going to take the text we have here and convert it to lowercase. Converting it to lowercase is a fairly common practice, especially when you have subsequent matching you need to perform. It can simplify the process. You may want to convert uppercase, or you may want to use some special capitalization techniques. Nevertheless, we're doing this to make our process a lot easier. Next thing we do, we use the trim method. The trim method goes out there and removes leading and trailing blanks. It unfortunately does not remove the blanks that are embedded inside the actual string. So if we're having any leading and trailing blanks, this will remove it. What we want to do in the next statement is use the replace all method to replace all the tabs with a single blank. Again, what we want to do is essentially reduce all the white spaces of multiple white spaces to a single blank. This will handle our tabs. Then what we need to do is use replace all again. In this case, we're using the first argument is what we're looking for, which is 2 blanks, and we're going to replace it with a single blank. We'll go through and use a while loop, and while the clean text contained 2 blanks or more, then it's going to do this again and again and again. This essentially removes all the white spaces, or actually collapse all the white spaces to a single white space, at which point we simply print the values out. Let's go ahead and run the program, see what our output looks like. And we find it does a fairly decent job here. It has all the letters and words been converted to lowercase. All our multiple spaces are replaced with a single space. And now this is considered to be clean, at least for the purposes of handling white spaces. So what we want to do is use the Google Guava library. It has several methods that makes this whole process somewhat easier and more efficient in some respects. What we need to do is modify our Maven project to include the files that we need to use Guava. So again, what we'll do is go down to our project files in our project. We'll look at the pom.xml file. Inside here, we want to add the dependencies for this particular Guava project. We do so by adding dependencies tags. We may have multiple dependencies. We'll use the dependency tag here to specify Guava using version 22.0. So this we need to do. We'll go ahead and build this project. That will go out there and pull in the files that we actually need. Maven provides a nice way of handling all of these different dependencies. So let's go back to our project. Next thing we want to do is to show a technique for doing the same thing we just did with the Java core classes. And this time around, we're going to use Guava classes. So what we see here is a splitter class and a char matcher class. So I need to fix the imports. So I'll right click, fix imports, and I found those. Go up here and verify the Google common base char splitter and base splitter. So these are the appropriate classes. We'll start the example off with just a print line statement that prints out a header. And what we'll find here is the splitter class has a number of methods, and that's using a cascading sort of approach here. The on method specifies what we're going to split on. In this case, we're using a char matcher class to specify we want white space. And any white space out there is defined by this class. Typically the blanks and tabs and things of that nature are treated, and when we actually do the split, it'll be done on white spaces. We may run across empty strings, so we'll go ahead and remove those. We want to trim the results. This will trim the white spaces around each of the words, not only at the very beginning, but also at the beginning and but also between the words. And the actual split method does the actual split operation, and using the text that we have defined earlier. We have not really modified that, so there's our text. And when we do the split operation, we return back an object that implements the interface on a string, allows us to use the for each method. This is the end of expression here. This is the Java 8 feature. What it essentially does, it says for each element of the iterator, what we're going to do is treat that as a token, as a string, and we're going to print that string out followed by a blank. This simply provides us a way of seeing how it actually tokenized or split that string apart. We then follow up with 2 blank lines to help with the appearance of it. So let's go ahead and run this, see what sort of output we get. I'll make this one a little larger so we can see previous output also. Notice we have the original text, we have the clean text performed using the Java core techniques, core classes, and we have the splitter example where we basically have gone through there, and in this case we have not gone to lowercase. We could have done this, but in this case I decided not to do so. But notice all the white spaces are basically multiple white spaces replaced with single white spaces. So this achieves the same results using a somewhat more elegant manner, at least in my opinion. We want to look at yet a third example how to do this. That turns out to be even shorter and a little cleaner. Understanding or have access to all these methods gives you a better set of tools, so to speak, in your toolbox to perform similar type operations. We start with char matcher example title, and we simply create our clean text. We use the char master white space method, which, as you can imagine, will do the matching on white spaces. It uses a clean trim and collapse from method. What this does is trims the white spaces at the beginning and ending of a string and collapses all the white spaces within the string into a single spaces. What we're working with is the text, the same text we used before, and again we're using this basically as what we want to trim, which is basically our white spaces. We then simply print the clean text out. Let's go look at the output real quickly. It really does not differ from the previous example. The splitter example, this is the output we had before. This is a char matcher example. Again, we get essentially the same output here. However, contrasting these two techniques, you'll see that this one is a little bit more elegant in many respects. So, these are two different techniques, or actually three different techniques if we include the original one, to basically remove white spaces and essentially collapse multiple white spaces into a single white space. There's one more thing I want to show you, and that again is using the char matcher class. But in this case, what we want to do is to remove, or actually process text and retain only certain portions of that text. And the char matcher method has an elegant way of doing that. Let me go ahead and paste this code in there and we'll see how it really works. We print a header again, char matcher retention example here, and then we use the char matcher class with several methods. This Java digit method says basically I want to match and return only Java digits. And so if this is all there was to it, all we get back from our string would be Java digits. We have an OR method here that says, hey, I'm also going to match on white spaces. So this is return not only digits, but also Java white spaces. Another OR method where we basically match Java lowercase letters. And so in this case, where we want to match Java digits, white spaces, and lowercase letters. The actual retain from method takes the string, uses as an argument, and returns back a string where basically it only contains Java digits, white spaces, and lowercase characters. Our example in this case is he is 5 feet and 6 inches tall. So we'll see both uppercase letters and digits and of course white spaces. Let's go and run the code and see what the output looks like. In this case, we'll see that the H is lost because we decided we do not want uppercase letters, only Java lowercase letters, so that goes away. He is 5, and notice we're actually missing the feet. The feet goes away, and the remaining text is retained. So this particular class is an interesting class. They have some interesting methods that we can use to help us extract information, retain information from text. Google Guava project has many other methods out there. You may find it useful to go out there and review that site and see exactly how it all works, see what's available to you.